Okay, so for this video, you guys are going to be doing is learning how to do, basically we're going to be reviewing the impulse, momentum, theorem. Okay, so basically this is relating impulse and momentum. So let's start off first with what momentum is and how we actually calculate it. So let's say, for example, you have this object. Okay, now this object, every object has some mass. So there's my m. Now, let's say this object is moving. Okay, that means that this object has velocity because it's moving. Now, because this object is now moving and it has mass, that means that it has some momentum. So P is momentum, and the formula for P, right, because you get momentum from the mass times the volume, the momentum of that object is equal to m times v. Okay? Now, let's go ahead and talk about what happens if you take an object that's already moving, so like this guy. Okay, so he's already moving. Now, the mass hasn't changed because it's still the same object. Okay, and it's still moving. Now, let's say that someone comes and applies some force to it. And as a reminder, a force is equal to a push or a pull. Okay? Now, because I'm applying this force, right, that means that this object, if I push it and it's already moving this way, it's going to start moving faster. So because of that, that means that the velocity has now changed. Okay, now the mass, if I push it, it's not going to change at all. It's still going to have the same mass, but the velocity will change. Now, because I applied this force again, or this push, then what happens is my momentum also changes because now it's not mass times velocity, but now it's mass times a change in this velocity. Okay? So, therefore, my momentum also changes. Okay? So, whenever I apply this force, so now this is what happens if I apply this force. Now, whenever I apply this force here, that actually has a special name. And that name is impulse. Okay? Now, if I apply that force, that means that because I'm applying this impulse, I'm applying a force now. Because time is passing, this force is being applied over time. So therefore, your impulse, which is symbol for it is J, is equal to force times time. So I'm going to take off the parentheses. The symbol for impulse is capital J. And impulse again is equal to a force applied to an object over a specific amount of time. Now, as we just saw, okay, if you apply a force to an object, and again because time is passing, it has now some impulse. And because of it has impulse, okay, what happens is that you also change its momentum, because remember, you apply the force, which changed the velocity, so therefore you changed this momentum. So therefore, impulse is actually equal to a change in momentum. Oops, running out of space. Change in momentum. Okay? So, let's go ahead and talk about impulse again, because we talked about two different things. So impulse actually has two equations. Okay? Now the equations for impulse are, again, J is equal to F times T, and J can also be equal to a change, right? So delta means change. This is change in momentum, which is P. Okay, now that says momentum, even though it's kind of hard to see. So this P symbolizes your momentum. Okay? Now, what does this mean for a problem? So let's say, for example, you have a problem that's telling you that you have an object. If you give me 1 second, I can find a pen. Yeah, I can't find a pen. Okay, so we're gonna go ahead and review this. So, before I continue, thank you. Now, just to recap again, we just talked about impulse and momentum. So, if you apply a force over time to an object, then that causes that object, which is this mass here, to change its velocity. Which again, this is your change in momentum, and force times time is equal to impulse, which is J. So again, J can be equal to either this formula, or this formula. Now these two formulas are pretty much the same thing except it's written in a different way. So this one is just the writing down the variables, this one's telling you what variables actually make up this formula. Okay, so now back to the practice problem. So let's say, for example, I have, okay, so I have an object moving at 5 meters per second, and it accelerates to 10 meters per second, and there's a force, okay, because of a force of 20 newtons applied to it. And now this object, it's a 10 kilogram object. Okay? Now they're asking us to find the time. Right? So first thing you want to do is go ahead and figure out what your variables are. So you have 5 meters per second, 10 meters per second, 20 newtons, and this tells me that it's force. And you know what the mass is, which is 10 kilograms. So this is equal to 10 kilograms. This is my initial velocity because it's moving at 5 meters per second. And then it's going to accelerate to 10 meters per second. So that's my V final or my V2. And I know that's velocity because meters per second. And here kilograms is because of mass. And they're telling me that I have this force of 20 newtons. So what I need to do is I need to figure out which of these formulas I need to use. Okay? Now, if I go through my variables, let me see if I can get both of these on the same page. Okay, I have force. I'm looking for time, right? And that's in seconds. I have velocity, which this formula here, but whenever you're talking about a change in something, what that means is that change, I'll write it under here. Change, or delta, means final minus initial. So delta V really means V final minus V initial. Okay? So therefore, that means that I have this part here, and I also have the mass. So now it's just taking my equation and manipulating it. So I'm going to write down my formula here. F times T is equal to M times delta V. And so I'm looking for time, so I'm going to divide by F, not T, on both sides. So now I have T is equal to mass times delta V over my force. Okay, so now hey, please watch your language, and I'm recording this, so I need you to be quiet. So my mass times my change in velocity, which is V final minus V initial, or you can also write V2 minus V1, which are the same thing, over the force. Now all you have to do is plug them in, and so you have 10 kilogram times V2, which is 10 meters per second, minus 5 meters per second, over my force, which is 20 newtons. Okay? Now, newtons I can also replace, because newtons are equal to kilograms times meters per second squared.
But that, I'm telling you that from the beginning. Later on, when you start understanding it, I'll probably say, you know, change. But actually, you're already learning this stuff.
Brian and Gabby. Gabby. Thank you. So again, newtons is equal to kilograms and meters per second squared. So I'm going to replace those newtons with that. Times meters per second squared. Thank you, Andrew. So then 10 minus 5 is 5. So I'm going to put 10 kilograms times 5 meters per second. You're heading out? I think I'm good. Thank you so much. That was a lot of help. Sorry, guys. So 10 kilograms times 5 meters per second. Okay, because I subtracted these two. Over 20 kilograms times meters per second squared. So that's going to be equal to 10 times 5 is 50 kilograms over 20 kilograms times meters per second squared. Now, if you look at your units, kilograms, meters will cancel out, and one of my seconds will cancel out with one of these. And then all I have to do is divide 20 into 50, and I canceled out the zeros because it's basically dividing by 10. So 2 into 5 is 2.5. So your time is going to be equal to 2.5 seconds. Okay? Now, they can ask you an even simpler question. So that's one example. That's using this formula, which is F times T, which is impulse, is equal to M times delta V. And this is called your impulse momentum theorem. Okay, but because this is basically two formulas in one, I can actually look for either just impulse or just a change in momentum. So I'm going to show you guys how to do that. So let's say you have an object. Okay, and this object, okay, so let's say you have a 10 kilogram object or car, let's say block. Okay, and you're applying 100 newtons of force to it, and that causes it to stop in 5 seconds. Okay, so again, you have this 10 kilogram block. Now someone comes and basically applies 100 newtons of force to it, and basically after 5 seconds that object comes to a complete stop. So this is my time, this is my force, and this 10 kilograms is going to be my mass. Now, for the first part of this question, they're asking you to find the impulse of this car. Alright? Now, for that, remember we have two formulas for impulse. So you can have impulse is equal to force times time, or impulse can also be equal to the change in momentum of something. Okay? And again, change in momentum is just mass times change in velocity. So we can use either of these formulas. So the way you decide which one to use is you look at the variables. So for this one you have force and you have time. So this is the only one that makes sense to use. So this one we're not going to use right now. So impulse is equal to force times time. So my force is 100 newtons times my time, which is 5 seconds. So the impulse that this object has or experiences is 500 newtons times second. Okay. Now part B is going to ask me to find the change in momentum that this force is now causing to this object. So if you remember, we learned a theorem that says change in momentum is equal to my impulse, right? So because we know impulse here, and that impulse is 500 newtons times second, then that means that my change in momentum is actually going to be equal to this, which is, and again, change is delta, momentum is p. So my delta p, or my change in momentum, is also equal to my impulse. Now, if I were to spread out this newtons, I would have kilograms times meters per second squared times seconds. So one of these seconds would cancel out with this one. So then your momentum, your change in momentum, would be equal to 500 kilograms. Okay. So that's pretty much it. Now, remember, another thing that they can ask you to do is figure out what the mass of that object is, or they can also ask you to figure out what the velocity of this object is. And the way you can do that is if you know the momentum, right, or the change in momentum, that means you can also figure out what the mass is, or you can also figure out what the change in velocity is. Now this is just like, these are separate problems. I was just telling you that you can take, if you know the change in momentum, they can also ask you for different variables. Okay. And that's pretty much it. Actually, I wanted to show you guys one more, which is, let's say they're asking for the change in momentum. So this one, they're going to tell you have this 10 kilogram mass. It's moving at, it started off at rest, which means it's going to have 0 meters per second. And it accelerated to now 10 meters per second. And the other thing is that they're going to ask you to figure out what the change in momentum is. Now this is all the info they're giving you. Now you need to figure out what change in momentum is. So remember, change means delta, momentum is p. And the way you get a change in momentum is if you have the mass times the change in velocity of an object. So we're going to go ahead and plug in values. So now I have 10 kilograms, which is my mass. Now my change in velocity, right, change is equal to final minus initial. So I'm going to take this one and expand it out. So therefore I'm going to have v final, which I'm going to write as v2, minus v initial, which is v1. Same exact thing as final minus initial. And now I'm just going to plug things in. So 10 kilograms is 10 meters per second minus 0 meters per second. So you have 10 kilograms times 10 meters per second. So 10 times 10 is 100. So your answer is 100 kilograms. That's your change in momentum. Okay. Now for part B, they're asking you to find the impulse. Now again, remember, the impulse momentum theorem says that impulse, write it out, impulse, that's an I, impulse, is equal to a change in momentum. So from our previous problem, we know what change in momentum is. So delta P, right, change of momentum, that's equal to my impulse. So therefore, my impulse, if it's the same problem, my impulse is going to be equal to my change of momentum, which I calculated in the first part. So it's going to be 100 kilograms. But our units for impulse are newtons times seconds. So, oh, don't worry about that part. So impulse basically is just equal to 100 kilograms. Okay? And that's pretty much it. Okay, thank you guys.